And welcome to the daily space weather. Looking at the sun at 304 angstroms. We see filaments. We see no sunspots. And we are getting hit currently by some solar wind. There's a geomagnetic spike happening right as we make the video. Let's look at some more views. Here's 193 angstroms. Not a lot to comment on there. Again, no sunspots. 10.7 centimeter radial flux. 68 solar flux units. Looking at the view from Stereo A's coronagraph, we actually don't see any coronal mass ejections today. And I'll let that play through again, complete with date stamps, before we move on to more data. Here's the ACE real-time solar wind, and we see a sudden density spike and a little uptick in the solar wind speed also, possibly because of a coronal mass ejection. And we've been seeing these happen daily for a few days now. You see a sudden shift in the phi angle there, currently at 339 degrees. And we saw solar wind densities as high as, looks like 20 protons per cubic centimeter there, about. Up to 66, I think I saw there. So very similar to what we covered yesterday, folks, just at the same time of day. And a little bit of perturbations in the solar wind speed. Looks like we're going to be around 400 kilometers per second, so not a significant solar wind speed. And let's look at the magnetosphere movies as we saw spikes coming in as I did show prep. Anyway, here's the velocity, and you're going to see at the end big time perturbations happening there. And here it comes. Here's those density spikes, and you can see the way they affect the magnetohydrodynamics. And here's the density, and you're going to see that sudden spike there. Big changes in the density, causing big changes in the geospace. Play that end portion again for you there. The density first started to roll in around 8 UT, once again, around 8 o'clock UT. And there you can see the high density represented in dark blue. Again, that happening right as we did show prep, and here it is in the pressure. Back this up, you can see very low magnetohydrodynamic pressure, followed by big spikes of high density solar wind. Not sure if that's the beginning of a coronal hole wind stream or coronal mass ejection, but if I had to guess, my first guess would be coronal mass ejection. We'll play that one more time on the pressure and then move on to geospace ground magnetic perturbations. Delta B, Delta B. And here's the geospace ground magnetic perturbations. Changes in the Earth's B field. Here we're approaching 8 o'clock, and you're going to see the standard issue global current spike. As welcome to the neo-renaissance, your planet's got Birkeland currents going in and out both poles. Or should I say all three poles? Let's look at the view from the poles. And here's 4 hours of that data also, providing you with timestamps to look up the oddities. If you're trying to correlate data, that's part of the purpose of our channel. And there we see big spikes coming in there, caused by that uptick in solar wind density mainly. And it looks like the biggest ground spike happened right around there, around 9:30 UT. And there's the image from that. Please don't forget to like and subscribe on YouTube if you enjoy the content. Press the notification bell, perhaps view the premieres with us. And also please consider supporting us on Patreon, as YouTube pays us precisely $0 to make these videos. TalkAboutSpaceWeather.com astutely noting that we have cycle 25 activity in the form of this plage here, and cycle 24 activity happening at the same time, something we cover daily on the channel. Again, 10.7 centimeter radial flux, back down to 68. I've drawn in a line at 70 solar flux units here. So you can see about where that line is. That's solar minimum. Let's move on to the, do you think the sun is conscious? And if so, what would you say or ask? Here's a 304 angstroms view. Please leave a comment with what you would say to or ask of the sun given the opportunity. Whether or not you think it's conscious, folks. Leave a comment. Let us know. Goes magnetometer. Still looking spiky here. Although we are currently fairly rooted in the North Pole associated portion of the heliospheric current sheet. Here's the Gong 2 data. You can see that's noted in green. We're expecting at least another 12 hours or so of North Pole oriented field. Not expecting the boundary crossing of that for at least, I'll say, 18 hours. And here's the last image. And you can see we're soundly in the North Pole portion, again noted in green. South Pole portion of the current sheet noted in red. Goes electron flux has dipped a little bit since yesterday. And we wouldn't be surprised if we saw a larger dip in this, again with that high density solar wind coming in. Relativistic electrons are pretty chilled out here. Still at kind of a high level, but not where they were. And the X-ray flux is pretty flatlined. Some oddities going on there. Some different data showing up at different spacecraft. This is the GOES 14 and 15 here. KP index solidly at 1 for the past 18 hours. And let's do the earthquake rundown. Past 24 hours includes this 4.9 at Papua New Guinea. That happening about 24 hours before this broadcast was recorded. Here's a 4.7 at Bhutan. That first quake, by the way, at Southern Mariana Islands was at depth. Next on the list, south of Australia, in between Australia and Antarctica, a 4.8 magnitude. Here's a 4.6 in Indonesia. And folks, the magnitude 7 and even the magnitude 6 earthquake drought is continuing, as well as the magnitude 8 earthquake drought. If you are in an earthquake-prone area, please have a plan. Have a plan to be an asset as opposed to a liability in the event of a disaster. Because if you're wondering who the cavalry is, it's because it's you. So, de oppresso liber. De oppresso liber, folks. Which means from the oppressed, the free. Next is a 5.1 in Indonesia. I believe that is the largest on the list. Basically, it's just an earthquake lull, big time. Here's a 4.5 at Indonesia. Not at depth. Here's a 4.5 at the Philippines. Pretty low levels of activity, folks. 4.6 at the Reconnaissance Ridge. South-southeast of Greenland. Here's a 4.3 at Russia. Off the east coast there. That one at 268 kilometers depth. Please leave a comment if you're able to view our videos from Russia. Here's a 4.9 at the South Shetland Islands, located very close to Antarctica. Here's a 4.9 at Chile. That one's at depth. Western South America remains my favorite spot for a larger quake. Here's the pressure maps on windy.com. We'll advance that about one day. If you see anomalous pressure zones after experiencing a deep earthquake, you may be the next on the list for a major earthquake. If you see a low pressure zone moving east to west, for instance, that is a risk factor. If you see a low pressure system disobeying the rest of the jet stream or skirting a plate boundary or just traveling north and south right along a plate boundary, those are all earthquake risk factors. Let's move on to the volcano rundown. And we see new volcanoes on the list. It's quite a long list today, actually, folks. So, first of all, we've got Abico producing a 10,000-foot ash plume there. Mount Aso erupting for weeks and probably months. Unknown of what the size of the cloud is there. Dacono producing a 7,000-foot cloud and exploding. Santiaguito back on the list, producing an 11,000-foot ash plume, exploding 1 to 3 times per hour, and weak avalanches on the southern flank. Please do not erect a campsite on San Chaguito. Pacaya in Guatemala now on the list also. Constant Strobolian explosions and lava flows. Mount Fuego back on the list. 4,800-meter ash plume there. Please don't fly your homemade ultralight aircraft over that. Revenador, probably still exploding, but not visible on the satellite imagery. Sabancaya, exploding, producing a 24,000-foot ash plume. Copahue, continuous ash emissions there. And Nevados de Chilean, intermittent emissions. Charging hazards are minor, and they're over places like Mexico and Central America. Here's the F2 ionosphere layer, and it's looking pretty anomalous. On both the day and nighttime side, we see a high charge and a high discharge. So you see that sudden large red blob form? That's the entire F2 layer devolving into an F layer at only 1 megahertz. And also you see a 14 megahertz charge over the Western Pacific Ocean. Here's the latest image. That one from 9 o'clock UT, looking a little more normal than it was a couple hours ago. Here's where stuff is in the solar system. And there's where stuff will be in 7 days around a full moon. And here we are at Plasmascape. Now yesterday we talked about the Pleiades. Today we're going to talk about the dog star, the brightest star in the sky, Sirius. Here's where stuff is above my head. Check out in-the-sky.org if you want to make a star chart for yourself. Lots of lightning over Central America and the Caribbean, as well as the Mediterranean. And here's your value-added US Doppler radar. It looks like today's bike riding will be rained out for me, as I am located in eastern Pennsylvania in the Lehigh Valley. Let's look at the water vapor animation here. If you're wondering how I became such a meteorology nerd, it's because of cycling largely. I wanted to be able to very accurately predict the weather, and being a physics nerd and somebody who's been deeply involved in science since before entering kindergarten, I prefer to know how the stuff works. And anyway, there's the situation for water vapor. And let's look at the area around Virginia Beach, as there's some moisture there off the coast. And we see this dry mass of air taking its good old time, pushing its way through where I am, and it's going to continue to bring bands of rain through my area for an extended period. Here's the jet stream scenario in the Western world. Please leave a comment if you live in the Eastern world and you're viewing our videos. We're going to show you the jet stream there in a moment. It looks like it's going to be a cold day in Washington and British Columbia, as there is Arctic air folding right down. Here's the eastern jets. And we see pretty extreme meridional jet stream flow there, folks, as the polar vortex is already forming. Let's take a look. And there's the 10 hectopascals view of the northern hemisphere, looking right down the North Pole, the geographic pole. And we see counter rotation. Let's take a look at the South Pole. And let's move on to censored versus sinkhole, where we talk about whatever we want. Hell yeah, Beto wants to take your AK-47s and AR-15s. Let's talk about some data on that matter. New FBI data just coming out from last year shows 5 times more murders by knives than rifles. Yeah, are you worried about AR-15s? Oh yeah, a lot of people are. Guess what? The rifle category includes bolt action, pump action, lever action, as well as semi-automatic firearms like AR-15s. In other words, all rifles. Anyway, handguns are what cause most murders. And we've got links to this article, as well as probably every other page that we've visited. 5 times more murders by knives than rifles in 2018, folks. This is a new one, just came out today. Tell your friends, tell your foes. Lots of fun for everyone. Talk about stupidity and ignorance. Self-driving cars are stupid because they don't have the right instrumentation to become safe. This is why they run over kids and they run over people of color more often than white adults, because they can't see them. Now, these tests were only done at 20 and 30 miles an hour, and guess what? At 30 miles an hour, they completely failed. Links to this article also. Let's talk about the real solution to this. The real solution is forward-looking infrared radar. Now, you can buy a cheap one that attaches to your smartphone for only $299. Check it out. It's a legit thermal camera, folks. Basically, Doppler thermal radar for your phone. You can get it in iOS version, micro USB, or USB-C. It's only $299.99. Directly from FLIR, forward-looking infrared radar. The real solution for self-driving cars, as Apache helicopter pilots will tell you, don't run, you'll just die tired, because you can't hide from the IR. Now, polar bears can hide because their fur is so insulative that these devices can't really see them, making the Arctic even freakier. But this is the real solution for self-driving cars, folks. These instruments need to be added. I mean, think about it. $300 increase in the price tag to stop from running people over? Seems like a good deal to me. What say you? Now, yesterday we talked about the Pleiades and Alcyon, the brightest star in the Pleiades. Today we're going to talk about the brightest star in the whole sky, Sirius, the dog star. Now, you can find this one also using Orion's belt. It's basically just going to be to the left of the belt. So you've got the Pleiades on the one side, on the right, you've got Sirius on the other side. It's part of Canis Major. And this is a binary star system. Here's a Chandra X-ray image of Sirius A and Sirius B together. And that's an awfully small image. Anyway, this object is located only about 8.2 light years away, 8.4 light years I think it is actually. And we've got links to this also here for you to read all about it. 8.6 light years is the distance to that object. And it's a bluish white star. It appears to have a 50.1 year periodicity with Sirius B orbiting Sirius A. Again, links to this wiki article in the description below the video. Let's briefly talk about Sagittarius A star, moving out a little bit farther. A lot of people think that supermassive, quote, black holes, end quote, just go around vacuuming stuff up all the time, but it turns out that only about 1% of available gas and dust gets accreted into the black hole. Is this because there are repulsive forces as well? Please leave a comment if you have a theory as to why this happens. This article is from 2013, and we've linked this in the description also. Have yourself a read if you were not aware of the behavior of Sagittarius A star. If you want to look at close-up stuff about the behavior of Sagittarius A star, well, check out the Neil Gorell Swift-Bat X-ray Observatory. On day 266, it looks like we had a full spectrum outburst from Sagittarius A star. Let's look at a couple other objects for reference. First, let's look at Crab, aka the Crab Nebula, located way on the other side of the galaxy, out on the western limb. And there are the transients from Crab Nebula. We'll look at the Vela Pulsar, which is kind of out toward the Crab Nebula on the same arm of the galaxy. There are the transients from the Vela Pulsar. Next, we'll look at Cygnus A, the strongest radio source in the entire sky. except for the sun. This galaxy is a massive radio galaxy located about 500 million light years away. There are the transients from that. No correlation between Sagittarius A star's outburst. In fact, more like an inverse correlation. Let's look at Cygnus X1, a massive radio source believed by people like Carl Sagan and Stephen Hawking to be a black hole, which they famously bet on back in the late 70s. There are the transients from that. No correlation there between Sagittarius A star's outburst and Cygnus X1. Next, how about Cygnus X3, otherwise known as Deneb, the high-mass X-ray binary? There are the transients from that. And we've put links to the Neil Gorell Swift Observatory Swift/BAT hard X-ray monitor. That stands for Burst Alert Telescope, folks. There are a lot of objects that are monitored all the time by radio telescopes. So check that out if you want to look for the transient outbursts of your favorite astronomical objects. How about some climate change nonsense? Courtesy of Cosmos Magazine. CosmosMagazine.com. More fuel for early Anthropocene. Well, it turns out the Maya were extremely sophisticated. They were using irrigation. They were removing forests in order to increase their farming output. And apparently, this article is about how people think that they made the climate warmer on the planet because they don't understand anything about the climate control knob, and they think carbon dioxide has something to do with it. Also methane. And so, yeah, they're trying to suggest that the human impact on climate change started 2,000 years earlier than the Industrial Revolution, or at least about 1,500 years earlier than the Industrial Revolution. Please leave a comment if you think the Maya contributed to climate change even while carbon dioxide levels are very low. And if you've never seen this graph, we show it on the regs on this channel. This is temperature in Celsius compared to carbon dioxide. And as you can see, the average level of carbon dioxide on the planet is more like 2,000 parts per million, not 400 and change where we are now. And as you can see from the graph, there really is not any correlation between temperature and carbon dioxide. Please can we move on and stop hearing about this nonsense? To this article on phys.org, extreme solar storms may be more frequent than previously thought. That's right, we are way overdue for a Carrington event type thing. And please leave a comment if you've got solutions as to how to prevent the entire planet's power grid from going down from going down for years in the event of a Carrington event-like scenario. While the 1859 storm was certainly one of the most extreme events, this seems to be at best comparable to the 1872 storm and 1921 storm in terms of its intensity. So the Carrington event is no longer something unique. Welcome to the Neo-Renaissance, folks. All stars are variable stars. This is not good news for the precariousness of the human condition or man-made civilization in general. It's just the truth. And we're not delighted to tell you, but we are delighted to call them like we see them, because when we stop calling them like we see them, we're fired. Again, if you enjoy the content, please like and subscribe. Please tell your friends and your foes. And share on your social media. Press the notification bell. We try to watch the premieres live so we can deal with comments in real time. Thanks Smash Team and everybody else who's viewing the video. We appreciate it, especially patrons. Stay tuned for a bonus feature. Just one today. Just one. And it's the local yellow dwarf at 171 angstroms. My personal favorite. We do see a little bit of activity rising in the east there. We see this active plage facing the Earth right now, as well as a little bit of magnetic activity south of it. There are your time and date stamps. We are out of here. Thanks for tuning in, folks. Remember, when you're staring at the sun, don't drink. If you drink, stare at the sun anyway. Just don't drive. Maybe get some Coleman's mustard. and put some hot mustard on your food. It's good for you. And since it'll never be now again, may the solar wind be at your back and the atherosclerosis absent from your veins.